Yeah, I hope everyone would have received the Google Classroom ID through
Yes,
your
sir.
class in church or to your official email ID. I had sent Google Classroom ID. So all the uh, presentations, study materials, any other information regarding mobile communication will be sent only through Google Classroom. So those who are joined, no issues. Those who haven't joined Google Classroom, kindly join the Google Classroom for getting any updates about mobile communication and networks for your class. I had sent you the Google Meet ID also in Google Classroom. So that ID is permanent. So whenever we have an online session, so you can access the ID and our meeting will start. For all the online class sessions, the Google Meet ID is common, ZIXTOQAQGR. I hope is my screen visible to all.
Yes, sir.
Is the screen visible?
Yes, sir.
Yes, sir.
Okay, thank you for your valuable feedback in the chat box. You have given yes, yes. Okay. Ramdas and Hariteja. Okay. Hmm. To start with mobile communication and networks, you need to be familiar with the basic prerequisites. So the basic prerequisite for understanding mobile communication is two different subjects. One subject is digital communication and second one is antennas. So digital communication you would have studied in your fourth semester, analog communication, digital communication. So the basics of the digital communication is to be understood properly. So if you are familiar with the analog and digital communication subject, you can easily understand the mobile communication and networks. And in addition to the digital communication subject, if you are chosen in your professional elective 1 as antennas. If you would have chosen this subject, would be more interesting and more understandable. It doesn't mean that if you had studied antenna only, you should study this. If you had studied, you can understand it in a better way. Okay, so I'm here to clarify all your doubts, to make you more comfortable, such that you understand mobile communication very easily. Okay, so need not worry. Though if you haven't studied antennas, I'm there here to help you. So may I know how many of you are not familiar with antennas or didn't study antenna as a professional elective 1? You can type in chat box, no issues. And type I'm not familiar, such that according to that I'll handle the classes. If it is known to everyone, no issues. I'll straight away go into the concepts. Not familiar, yeah. Okay, 2 members, Lokeshwar, Manasa Krishna. Okay. Okay, 6 members. Why I'm asking this question is that depending upon your responses, I will, wherever necessary or wherever time is given, I'll bring out the concepts of antennas also. So that is what I'm raising a question like this. Because the fundamentals of mobile communication is that it is wireless. It uses antenna. So the type of antenna is not a concern. It uses an antenna. So you need to know how an antenna works, what are its characteristics, what are its features, what are its drawbacks, what are its advantages. Only this much is enough for mobile communication. So I am able to see some responses. Okay. Some 10 members had given so far. They are concerned that they are not familiar with antennas. No issues. So that antennas I'll cover when we take a unit number 3. All your queries, because most of the antennas part comes only in unit 3 and unit 4. So you don't worry. During the sessions of unit 3 and 4, I will cover all the basics of antenna concepts, such that you will be able to understand or confidently say that you had learned mobile communication networks in depth. Okay. Thank you for your feedback. Okay. So basic knowledge about initial communication and antennas plays a vital role. Okay. So let us see the objective of this subject. You might be thinking, why I joined ECE. I had studied 3 years, 4 years, and why should I study this type of subjects? ECE. ECE is meant for only communication or electronics, or everybody can study ECE. That is not the case. Each and every subject has its own objective. Nothing is as such like that. You cannot learn without any objective. So each and every subject that you are studying in ECE has its own value. So the value of the mobile communication is that if you go for any systems nowadays, if you go for any systems, all the systems are meant for communication. Why we go for communication? The main reason is that to minimize your cost of expenditure on travel, to minimize your efforts on the travel expenditure, in order to convey your information to the desired person or to the desired point, or to deliver information what you want to deliver to the person at the longer places. So if they are present at a distance apart. Okay, so that is the basic purpose of communication. So communication is transfer of informations, either in the form of text, texts, data, voice, SMS, videos, anything could be your communication signal. Okay, so that could be your information. So that information, what you are having, is to be delivered to the person that you want to transmit, or to whom you want to deliver them. So that is communication. So in olden days, we used electrical cables connecting the transmitter and receiver sections, or connecting point 1 and point 2. Then we had moved on to telephone cables. Then we had moved on to optical cables, which are physically in touch with the sender point and the receiver point. So whereas when we go for wireless, it is that these 2 points which are being connected in wire is connected wirelessly. So the points, transmitter or sender, receiver or destination, which have been connected physically through wires or cables or optical cables or optical wires, have been changed to wireless modes nowadays. Then after a few years, or after evolutions, these points, the sender point and the receiver points, which were fixed in nature, which were initially fixed, that means they will be present only at that point. The antennas which were fixed at the transmitter and receiver will stand still as it is. They were not in motion. So the devices which were being deployed, or the evolution systems, made the stationary points or the fixed points which contains these devices were moved as mobile. Mobile in the sense movement. Moving from one latitude longitude position to another latitude longitude position. I think you all are familiar with the latitude longitude positions. So latitude and longitude are the imaginary lines on the earth that are being present or that are being drawn for determining the position of the devices or points or whatever we want to measure. So the evolution changed from wired medium to wireless medium. Then the evolution changed from fixed points to stationary points. So in this case, what happened to the technology is that in the wired cases, we were able to transmit only a few bits of information in the initial stages. So as soon as we used the advancements in the telephone cables, we had got more information transmission. We were able to transmit at a better data rate or better bit rate. Then optical fibers provided even more higher data rates as compared to the wired systems. So then these cables were replaced by wired by wireless. So again, we need to get that much of data rate or bit rate as we had got when we used wired telephone cables. Or optical cables. So still research is in process. Still, still research is in progress to achieve bit rate or data rate as we had wireless cables. So that research is still in progress. So in this subject, we are going to deal or we are going to understand the issues involved in mobile communication system design and analysis. What are the issues in designing and mobile communication, transmitter design, receiver design, its parameters, its analysis. Then the next objective why we need to study this mobile communication is that in mobile communication uses antennas for its transmission and reception of signals. Every signal that is being transmitted or received will possess a frequency. So the concept of frequency reuse we are going to see in depth in this subject. How the frequency is being used, what type of frequency is used, how to manipulate them, how to design it. Then the different characteristics of wireless channel. As I said, the channels are the connecting points between the transmitter and receiver, or the source point and the destination point. So if the channel is a wireless, if it becomes wireless from wired, it possesses some characteristics. So what are they? So that you are going to estimate, that you are going to analyze. that we are going to study. So that is the third objective, to understand the characteristics of wireless channels. Then the next objective to study this subject is that the capacity of the wireless channels. So what are the fundamental concepts involved such that these wireless channels can accommodate? Okay, for example, if you are having a house which is of 100 square meter, 100 square meter house, and you are bringing a pot to store some grains, or to store some valuable, or to store your food grains or wheat or whatever might be. You are bringing a pot for your house which carries, which can accommodate 10 kilograms. Let us assume 10 kilograms. Okay, one day you are bringing 5 kilograms of food grain, you are depositing that then that will accommodate. So after 2 or 3 days you are bringing 10 kilogram or in excess of 10 kilogram. Will that pot accommodate? Obviously it will not accommodate, because already 2 days before you had filled it with 5 kgs. Today you are bringing 10 kgs or more than that. Then the capacity of the pot cannot accommodate what you are bringing, because the capacity of the pot is less than what you are bringing. Okay, so the same occurs in channels, and it is the same for your wireless channel. So how much amount of information can be sent onto the wireless channels is to be known. So without knowing that, you cannot send any data signals. So that's what the study in digital communication as Shannon theory, or Shannon coding theorem, channel capacity theorem, source coding theorem. So those are the theorems that have been deployed for transmission of signals. So that we are going to modify as per the requirements of the applications in order to determine the capacity of wireless channels. So that is the fourth objective of this mobile communication and network subject, knowing the fundamental limits of capacity of wireless channels. Okay. So I'll give you an introduction about the 5 different units in correlated for mobile communication and networks. The first one is Unit 1, cellular concepts. In this unit, we will be discussing about the wireless standards, first generation, second generation, 2.5 generation, third generation, fourth generation. And in the upcoming standards, we have 5Gs, 6Gs still under research. So the wireless standards concepts, then how a cellular mobile or a cellular structure is formed, how frequency is being reused, the concept of that, cell splitting, handoff strategies, power controlling, and so on. So in unit number 2, we'll be saying about the wireless channels, what are the mechanisms or the parameters being involved, like reflection, diffraction, diffraction, scattering, principles of a signal, and at receiver, due to the presence of reflection, diffraction, diffraction, fading occurs, which could be classified into large scale fading and small scale fading. The parameters for them, such as the Doppler shift, then power delay profile, dealing as how to manipulate or how to calculate Average and root mean square delay spreads, an important parameter which determines the fading, which is your coherence bandwidth, coherence time, the bandwidth for flat fading, frequency sensitive fading, slow fading, and fast fading. So all these concepts we'll be seeing in unit number 2. Next, in unit number 3, we'll be seeing the basic concepts of antennas, different types of antennas, the structures of antennas, antennas used specifically for mobiles, then the antennas which are used at base stations, its types, and so on. We'll be seeing in unit number 3. So at unit number 4, we'll be seeing the multi-antenna communication. In that, when more than one antenna is being used at the receiver switching system, so we have the diversity receivers, MRC, maximum ratio combining receivers, rake receivers, and equivalent equalization techniques to minimize losses. The transmit diversity scheme, the Almonte scheme, all we are going to see in unit number 4. Next, in unit 5, we are going to see the special cases of MIMO, multiple input, multiple output technology, used specifically in spatial multiplexing for higher data rate transmission in wireless communication systems. Then we'll be seeing the spatial multiplexing, a type of technique that is used for processing of signals at a higher data rates. Its performances, signal to noise ratios, bit error rates, all comes under your MIMO and multiplexing. So in addition to this, we'll be seeing a specific examples of mobile communication, which is GSM, Global System for Mobile, Edge, Enhanced Data Rate, GPRS, General Packet Radio Service, IS-95 Interium Standard 95, CDMA 2000 and WCDMA, which is Code Division Multiple Access, 2000 technology, and Wideband Code Division Multiple Access. After seeing all this, or after studying all the 5 units, you will be able to understand the following 3 important points at the end of the course. At the end of the course, you will be able to understand the working principles of mobile communication. You will be able to understand the relation between the user futures and underlying technology that is used in mobile communication. And another outcome is that you will be able to analyze which type of communication system is used for which type of application. So depending upon the application, you will be able to analyze which standard or which technology is better in what way. Okay. So the references or textbooks that you need to follow is Mobile Cellular Telecommunication System by William Lee, Mobile Radio Communications by Raymond Steele, CDAB Principles by A.J. Viterbi, Wireless and Personal Communications by V.K. Garg. This is the prescribed textbooks or references for mobile communication networks. And for most of the concepts, you can read or you can study Wireless Communication by Andrea Goldsmith. Wireless Communication by Andrea Goldsmith. So which covers 95, 92, yeah, 90% of your syllabus is being covered in that. So if you have any queries till now, you can type in chat box. I'll give you 2 or 3 minutes time for addressing your queries. If you have any queries, till this you can type in chat box. I'm ready to answer for your queries. Yeah, since I couldn't find any queries. Yeah, since I couldn't find any queries, I proceed on to the uh, second part of today's session, which is starting Unit 1 with its introduction. So I have divided the presentation of Unit 1 into two parts. One is part 1, Mobile Communication Networks, Unit 1, Part 1, Cellular Concepts. Unit 1, Part 1's presentation outline is outline starts with the concept of cellular, followed by frequency reuse, channel assignment strategies, a specific handoff strategy, interference and its types and its capacities, which are co-channel interference, adjacent channel interference. Then the concept of trunking, grade of service. Next, improving coverage and capacity. Next is cell splitting and sectoring. Then repeaters for range extension. Then microcell zone concepts. So all these things we are going to see in Unit 1, Part 1 presentation. So my presentation starts with the first topic of Unit 1, which is cellular systems basic concepts. So first let us see what is the necessity for cellular. Okay. So the cellular system solves the problem of spectral congestion. So what is a spectral? Is that the electromagnetic spectrum that is being used for transmission of your signals. You have heard right 10 years before about the 2G spectrum. Right, there is a scam of 2G scam, meaning that the spectrum which is being available is being misgiven to somebody else by making some alterations in the quotation being given by the appropriate departments in the government of India. So with that, spectrum is nothing but the electromagnetic spectrum, which varies from low radio frequency signals to super waves, microwaves, and even the optical waves. All comes under your spectrum. So to solve the problem with the existing spectrum, the cellular systems were being used as a solution for that. So you might be asking, what are those problems? So the problem is that congestion. The congestion is if you have a single point, if you have a receiver at the same time, consider a receiver having a point. So that point which receives all the time gets signals from different transmitters at a time. At a time, if you are able to retrieve one signal, it's very good. At the same time, a receiver cannot acquire or cannot decode multiple signals at a receiver at a single time. So this is what congestion. This is called as congestion. So the cellular systems provided a very good solution to this spectral congestion, so which offered a high capacity with limited resources of spectrum which is available. So how this was achieved is that high capacity is achieved by limiting the coverage of area of each VS. VS is your base station to a small geographical area called cell. So from your transmitter to the receiver, I'm sending some signals from transmitter to receiver. So during these transmissions, the signal will travel through multiple areas. So those areas are being divided into small geographical areas or geographical cells. So each geographical area or each geographical cell will have a base station. In short, we call it as a tower or a booster. Tower is what normally you assume it. Okay, and a tower could be a base station. Is an example. So with this, high capacity is being achieved. So how it is being achieved is what we are going to see in this 5 units. Okay, so high capacity is achieved by replacing high power transmitters with several low power transmitters, and each base station is allocated a portion of total channels each base station is allocated a portion of total channels, where the nearby cells are allocated completely different channels. So if there are, for example, 3 or 4 areas having some channels, only a part will be allocated with base station channel. The remaining all will be allocated with different channels which are nearby to them. Next is that all available channels are allocated to small number of neighboring BS or base stations. Small number of base stations. Rather than having a single base station for a geographical area, each will be divided depending upon geographical area into small cells. So each cell with each base station. So, and by removing the interference between neighboring base stations, by minimizing the okay, the interference that is being occurred by the base stations is being minimized by allocating different channels. So here we use frequencies. For every transmission of your signal, frequency is being utilized. So same frequencies are reused by some factors. So the factor of 5, factor of 7, factor of 3 are being used by spatially separated base stations. So the interference between the co-channel stations is kept always below the acceptable level. So what is interference is that multiple signals, when it falls on a single point or on a single receiver, it doesn't know which signal to take off. So in that case, if it takes information, the signal will be getting interfered with each other. So that a type of interference you have studied in your digital communication called as intersymbol interference. One signal which is traveling at one rate overlaps with the another signal traveling at a different data rate. So in that case, two signals will interfere with each other, where the signals symbols will mingle with each other to produce a noise, so which we call as intersymbol interference. So this should be maintained to a acceptable level. So next is the frequency reuse concept. So this is used by most of the cellular network to improve the efficiency with the limited radio spectrum. So this frequency reuse is being reused after covering a certain distance. The radio wave gets attenuated when the signal falls below a point where it can no longer be used or it cannot cause any interference. A transmitter transmitting in a specific frequency range will have only a limited coverage area. So beyond this coverage area, that frequency can be reused by another transmitter. So only for a certain area, we can use that frequency. So beyond that region or area coverage, that frequency will not be available. So again, we can deploy that same frequency. So and it goes on. So that I'll show you in a diagram such that you'll be understanding it in a better way. Okay. So the entire network coverage from transmitter to receiver is divided into cells based on the principle of frequency reuse. So I'll show you the frequency reuse concept also in macro cell or micro cells. So a cell, which is basically a geographical unit of a cellular network, is the area around an antenna where specific frequency range is being used. So when a subscriber moves from one cell to another cell or from one region to another region, the antenna of the new cell takes over the signal transmission. So as you have seen some 10 to 15 years back, when you move from one geographical region, for example, if you move from a city region to rural region or the urban region to rural region, what it will show is that your mobile networks or your mobile network operator will show you a caution of R in your mobile display, which is roaming. Or when you move nowadays from one state to another state, if the network is not covered under non-geographical region, when you move from one state to another state, for example, if you are moving from Andhra Pradesh to Tamil Nadu, your mobile network will show you a symbol called ROR, which is roaming, which is due to this geographical region separation. So when a subscriber, so that is the meaning, when a subscriber or the user moves from one geographical region to another geographical region, the antenna will take the transmission link of the new cell. So that is where roaming occurs. So then this cluster or group of adjacent cells is taken into consideration with some frequency reuse factors. So usually we take 7. The reason also I'll explain you. Then the frequency spectrum is divided into subbands, and each subband is used within one cell of the cluster, and that too in the heavy traffic zones. Always the cell zone will be minimum or smaller, and in isolated places the cell size will be larger, such that it provides more efficient data in order to obtain good data traffic management. The design process of selecting and allocating channel groups for all the cellular base stations within a system is called as frequency reuse or frequency planning. The cell labeled with the same letter can use the same set of frequencies. Same letters or frequencies can be reused again and again. So then the cell shapes can be given in the form of circle, square, triangle, hexagon. In all the concepts, hexagonal is the shape which is being preferred and it is conceptual. But in reality, it is irregular in shape. Okay, the cell shape. So this is your cell shape. So this figure is for frequency reuse factor 7, which illustrates the cellular frequency reuse concept. The cells with the same letter use the same set of frequencies. You can see a cluster is outlined in bold. Okay, you can see that there are 3 clusters. This cluster is outlined in bold. This cluster is outlined in bold and replicated over the coverage area. So the cluster size is taken as 7. So the frequency reuse factor is 1/7. And each cell contains 1/7 of the total number of available channels. If the total channels is 100, so 100/7, which is being divided equally in each and every cells. So you can see that A, B, C, D, E, F, G is a cluster. So inside this cluster, there are 7 cells. So cell A operates with frequency A. Here cell B operates with frequency B. Here C, here D, here E, here F, here G. So this is one cluster. So when you see the neighboring cluster, also same. A, B, C, D, E, F, G, H. Another neighboring cluster, A, B, C, D, E, F, G, H. So now you see that the frequency whichever is used in A will not be used in B, not be used in C, D, E, F, G respectively. One cell and the adjacent cell will not have the same frequency. But whereas A in cluster 1 will have the frequency as same as A in cluster 2 and same as A in cluster 3. So what will happen is that when you see that the cluster is formed as such, see the neighboring cells. A and C dissimilar frequencies, A and D dissimilar, A and D dissimilar, AF dissimilar, AG dissimilar, AB dissimilar in cluster 1. So when you compare, when you see with the second cluster, you can see that these 2 clusters I am showing you, B and F disjoint, C and D disjoint, C and G disjoint, D and F disjoint. So here also you can see B and D disjoint, E and G disjoint, and it replicates. Replicates in the sense it duplicates again in this fashion for frequency reuse factor 7. So here interference is being neglected, frequency is used efficiently, which is our main objective of the cellular system. So the high capacity is achieved, whereas interference is also minimized. You can see that interference between neighboring base stations is minimized by allocating different channels. So I have some queries. Let me address it. Same set of frequencies are used for radio channels located in different areas called frequency reuse. Yes. Every cell named as A uses the every cell A wherever we have A, same frequency is used, but different channels. Same frequency. Yes. Same frequency, different channels. A will have some frequency, for example, 1000 megahertz. 1000 megahertz. Okay. A will have 1000 megahertz. For example, assume 32 channels are available. Okay. Right from 1000 32. I have 32 channels in a cell of any cluster. So 1001 to 1032 will be allocated for A if there are 32. So then 1036 to 1000 another 32. So 32 is, 48 will be allocated for B and so on if 32 is the channel size. And it goes on. So such that one frequency doesn't overlaps with the other frequency. So in that case, for example, I'll show you here B and F. If F is, we'll assume it is 2045, 20402, 207. If F is 2042, 2042, 2072 megahertz, just an example. It's not exactly the same. For example, I take. So B is what? B is 1036 to 1048. Now, in this scenario, in this cluster, will this B and F be same? No. B and F. Is it same? As you said, no is the answer. Then overlapping or your interference. Not okay. If it is the same frequency, it can overlap, but it is not the same frequency. So this is how the frequency is being reused. So frequency is reused, then we'll get more amount of data to be placed on the same clusters, which will in turn increase higher data transmission. Okay. Any other queries? If you have queries, you can type in chat box. No issues. I'm ready to clear your doubts. Here each cluster is being differentiated by bold outlines. You can see that darker cluster 1, cluster 2, cluster 3. Each cluster will be having 7 cells. Each cell will have frequencies, and so those frequencies will be divided among the channels that it is being available. It starts with 32, 64, 120, it goes on. It depends upon the application that we use. Okay, so it's no queries. I proceed on to the next slide. Basically, in concept wise, the hexagonal shape model is being used. So in hexagonal cell model, the base station BS, base station transmitter is at the center of the cell or on its 3 vertices. I think you are familiar with vertices. Okay, vertices is that this place. The transmitter, base station transmitter will be at the center or at the vertices at this place where here the joining of B, C and A here, or A, C and D here, or A, E, D here, or A, F, E as here, or G, F, A here. Here the base stations will be placed in hexagonal model structures. So this base station will cover approximately 20 kilometers in rural. For every 20 kilometers, one base station is to be deployed. In urban, for every 2 to 5 kilometers, the base station can be deployed nowadays for improved coverage. And these base stations are omnidirectional in nature, means the antennas that propagate signals will be propagating or will be moving in all the directions. Omnidirectional, 360-degree. So SLR system will have S duplex channels. Each cell will be allocated with K channels. So always K will be S and S. S is equal to K into M. This is a factor. Yes, Manasa, your query is correct, and you are given the answer also. So the choice of hexagonal is that when you see a circle, you draw a circle and keep the base station either at the edge or at the center. It may not cover all the area of coverage will not happen. Why? Because at some particular points, when two circles are drawn, they will not merge over. Okay, they will not merge at all. Even in the equilateral, even in the square also. Okay. Why I'm calling the shapes to merge is that if merging is there, then only when the mobile or when the device moves from one geographical area to another geographical area, signal will be present. So that is achieved in hexagonal shaped structures conceptually. So that is why the choice of hexagonal is being considered rather than circle, equilateral triangle, or the square or rectangle, whatever might be. Only hexagonal is being considered. Why? Because even though when we place it at the edges or when we place it at the center, one will one area of coverage of base station will overlap with the other area of coverage of the cell. Okay, cell's area coverage, it will overlap such that during the movement from one cell to another cell, the signal doesn't gets lost. If signal is lost, information will not reach the appropriate receiver. So communication will be failed. Okay. So how do we calculate these clusters? Or how do we find the capacity of each and every cluster or cell? Okay, if cluster is present, always our cluster will be present. Depends upon the group size. Okay, so if cluster has C as the capacity and M which is being repeated for every A repetition, B repetition, 3 repetition, sorry, C repetition, D repetition, E, F, G repetition, which is your factor. Okay, M is the repetition. So then the capacity can be calculated by C is equal to M A N, so where N is the number of cells. Okay, number of cells. So together we can write C is equal to MS because S is equal to AN. The number of available channels S is K into M. So we can easily find the capacity of this cellular system. So always the capacity of system is directly proportional to the number of times cluster is repeated. The capacity of system is directly proportional to the number of times the cluster is repeated. So reducing the cluster size N while keeping the cell size constant, more clusters are required to cover the given area and hence more capacity. So frequency reuse factor, when the cluster size is 4, 7 or 12, we can use this type of cluster sizes. Cluster size is that one cluster with 4 cells, 7 cells or 12 cells. So the geometry of the hexagonal is such that the number of cells per cluster, that is n, can have only values which satisfy the equation n is equal to I square plus ij plus j square, where I and j are integers. If, for example, if I use I is equal to 3 and j is equal to 2, my n size will become 19. Applying in the formula. Okay. So normally in the GSM standard, global system for mobile, the frequency reuse factor is 7. Okay. 7 is the frequency reuse factor. So that's what I had shown you in the diagram. So next is locating co-channel cell. So this forms the area of coverage from one point to another point. I had used, for example, I am taking a A. A is the frequency, or A is the cell. How do I locate this cell in all amongst all the clusters? And see that this diagram is expansion of this. So here I labeled A, B, C, D, E, F, G. I labeled here. So similarly, I labeled for the second cluster, labeled for the third cluster, and so on. If there are more clusters being available, how do I find that particular cell? Okay. So how do I locate is that I can easily locate it by its frequency. Reason is this will have the frequency as such as this. This will have the same frequency as such as this. So this will have the same frequency as such as this. So the frequencies can be identified. Sorry, the cells can be identified depending upon the frequency being used, because all this acts within the same frequency. Okay, A is repeated, so this A is repeated. So this A is repeated. This A is repeated. Okay, so this is how to locate co-channel cells. Next is channel assignment strategies. How do I assign informations, or what are the protocols required for assigning information to each and every channel? A scheme for increasing capacity, that is increasing the data rate, and minimizing interference, which is decreasing the losses, is required. So the channel assignment strategy can be classified into either fixed or dynamic depending upon the application. So it could be either static or moving depending upon applications. So the choice of channel assignment strategy impacts the performance of the system. If you use a fixed system, you will be getting more coverage. If you use a mobile system, or if you use a dynamic system, you will be getting lesser coverage. So that depends upon the assigning. Okay, that plays a major role in the channel assignment strategies. So in fixed channel assignment, each channel is assigned a predetermined set of voice channels. Predetermined in the sense it is already fixed. So these are the characteristics. So these are the voice channels. These are meant only for voice channels. These are meant only for video channels. These are meant only for data text channels. So that has to be fixed. Or that will be fixed by when we use fixed channel assignment. Okay. So any call attempt within the cell can only be served by the unused channel in that particular cell. So if I have a cell, for example, A, I am taking, there are 32 channels at a 32 channels being present at a time. 30 channels are being used, and a call is coming. Okay, somebody is calling to that fixed system. So somebody is calling. Channel number 1 to 30 is being used. It is being utilized. Okay, so channel 31 and 32 are free. So depending upon the nearest availability, either 31 channel number 31 will serve, or channel number 32 will serve. Okay, so a call attempt within the cell can only be done whenever a call comes. Only it can be served only when, if there is an unused channel in that particular cell. So that is why sometimes when we use BSNL network, at your mobile phones. Okay, BSNL networks. Sometimes you get call busy or network busy. From 10 to 5 to 10 years back, when you use this type of operator, they used to say that network busy, network busy, network busy during peak hours. Probably in the morning 8 to 11, and in the evening after 7 or 8 till 10 or 11. Anytime when you try to attempt a call, when you make call to others, or when a call is coming to you, sometimes you may get network busy. So that is the reason. This is the reason. Okay. That we call it as blocked call. If all the channels in the cell are occupied, the call is blocked. So that's what you get. Network is busy. This is what had happened in a fixed CAS. Next, in the dynamic CAS, dynamic channel assignment scheme, strategies, they had used that the voice channels were not allocated to different cells permanently. In the sense, the voice channels were allocated temporarily only to a certain limit. Not all the channels. Only few channels were being allocated for voice. So each time a call request is made, okay, each time a call request is made, the base station requests a call from the MSC. Okay, I'll tell you. In depth, we will see what is this MSCs. Mobile switching center it is. Okay, the mobile switching center is a device from where a call is being requested, which acts as a sender or a receiver. Okay, so every time when you make a call, whenever in your mobile phone, when you make a call, the mobile will send a signal to the base station in your area or in your cell. Then the mobile switching center or a mobile device will allocate a channel requesting the cell to use an algorithm. Okay, to use an algorithm that has these many features. The first feature is that blocking. Second is that it should not cause interference and other parameters like cost. It should not take much cost for making a call. Okay. So the mobile switching center will have all the features. So whenever a call is being requested from the mobile switching center, it goes directly to the base station, and the base station will send request to that cell, to the receiver cell where the user is being present. Okay. So to ensure minimum quality of service, the mobile switching center only allocates a given frequency. Only certain amount of frequency will be given. If that frequency is not currently in use, in the sense all the frequency channels in that particular cell, if it is not in use, it will become limiting reuse distance. Okay. Then the dynamic channel assignment reduces the likelihood of blocking and increases its capacity by using this limiting reuse distance. So this dynamic channel assignment requires mobile switching center to collect real-time data on channel occupancy and traffic distribution on continuous basis. So these are the two different types of strategies being used. Fixed channel strategy and fixed channel strategy and dynamic channel strategy. So with this, I stop today's presentation. I'll check for some of the queries. No, here MSC is mobile switching center. It is not master control. The expansion is mobile switching center. As you would have seen, BSNL telephone exchanges, which are being deployed nearby roadsides. Somebody would have seen where it uses multiplexing, demultiplexers, and multiplexers are being deployed. Where signals are being switched from one area network to another area network. Okay, it's mobile switching center in GSM. So any other queries? Master control for mobile phone. It was earlier, but not now. It was earlier when landline phones were being used. It was acting as a master, but not nowadays. Advantages is that we are having more amount of bandwidth with a limited spectrum can be done. Rather than expanding the spectral or the spectrum of radio frequency, rather than expanding the existing spectrum, we can reuse the same frequency for enhanced transmission of your data. And this is an advantage. We couldn't find any disadvantage. Only if the disadvantage is that if the factor frequency reuse factor is less than 7, it is less than 7, more interference is caused. Yeah, I have shared the attendance link for today's session, and the link will be active till 4 p.m. of today. The students, those who fill this form only, will be given attendance. Check the attendance link in chat box. Okay, any other queries? That is what I said. If n is being reduced, if the reuse factor, if it is less than 7, is less
Sir,
than,
it is not accepting responses.
not accepting.
Attendance.
Just a moment. Yeah, try this link. Yeah, then I'll keep the link open for another 10 minutes. Yeah. Okay. If you have filled the form, you can leave. If any other queries, you can type in chat box.